video number 1 for checkpoint quiz 11.9. Problem number 1. Let v be the vector 4 square root of 3, comma 4, and u be the vector -1, comma square root of 2. Part A, find the dot product u dot v. This is going to be a scalar. When we compute the answer, we will have a number and not a vector. The scalar product u dot v is equal to u1 times v1 plus u2 times v2. In this example, the scalar product u dot v will equal 4 square root of 3 times -1 plus 4 times the square root of 2. And you can simplify that scalar product u dot v as -4 square root of 3 plus 4 square root of 2. And the only thing you can do there is factor out of 4, and you have the scalar product u dot v as 4 times parentheses square root of 2 minus the square root of 3, which is a real number. Part B, find the angle theta in degrees between the vector u and the vector v. The definition says cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. And we already know dot product is u dot v is equal to 4 times the square root of 2 minus the square root of 3. Let's compute the magnitude of v. The magnitude of v is equal to the square root of 4 square root of 3 squared plus 4 squared. And the magnitude of v can simplify as the square root. Now 4 square root of 3 times 4 square root of 3 is 16 times 3, which is 48, plus 4 squared gives you 16. The magnitude of v is the square root of 48 plus 16. Simplify as the square root of 64, and the square root of 64 is 8. So the magnitude of v is 8. Likewise, we can find the magnitude of u is going to equal the square root -1 squared plus the square root of 2 quantity squared. And when you simplify, you find the magnitude of u is the square root of 1 plus 2, which can simplify as the magnitude of u is the square root of 3. Putting those respective quantities into the formula, we would find the cosine of theta, and that is 4 square root of 2 minus the square root of 3 divided by the square root of 3, and the magnitude of v, which was 8. And when you simplify, you write the cosine of theta is the square root of 2 minus the square root of 3 divided by 2 square root of 3. And you can rationalize the denominator to give you the cosine of theta is equal to the square root of 6 over 2 minus 1/2. And now taking the inverse cosine, we find theta is approximately 43.6 degrees. Part C, find the orthogonal projection of the vector u onto the vector v. Orthogonal projection of u onto v. Well, the formula tells us that we can find the projection of u onto v is equal to the dot product u dot v divided by the magnitude of v quantity squared, times that by the vector v. So this will give us a vector answer. Well, we've already computed those components. We know the projection of vector u onto vector v is going to equal 4 times the square root of 2 minus the square root of 3 divided by the magnitude of v, and the magnitude of v was 8 quantity squared. And we're dotting this with the vector v. And when you simplify, you find the projection of u onto v is equal to 4 times the square root of 2 minus the square root of 3 over 64, dotted with the vector v. From here, you can reduce 4 goes into 64 16 times. So you have the projection of u onto v is equal to the square root of 2 minus the square root of 3 over 16 times by the vector v, and the vector v was 4 square root of 3, comma 4. From here, if you wanted to compute that as a decimal, you can go ahead and do it.